Welcome to Center of Math, Advanced Knowledge Problem of the Week. For this week's problem, we're given that we're given a non-commutative ring R. We're given elements A, B, and A plus B are all units in R, and we want to prove that the inverse of A plus the inverse of B is also a unit in R. So we're going to do this by explicitly constructing the inverse of A inverse plus B inverse. So first, we're going to write our unit in our commutative ring R is equal to A plus B times A plus B, the inverse of A plus B. And this is equal to A times A inverse plus B inverse times B times A plus B inverse. Note that this is just A plus B because we multiply A inverse becomes the unit. And then B on the right side, unit times B is just B. B inverse B is a unit. And then A times the unit is just A. And now we're going to multiply both sides here by A inverse A. Yeah, we're going to multiply by A inverse on the left and A on the right. So multiplying by A inverse on the left, A on the right, we get A inverse A is just 1 again. So 1 equals A inverse A equals A inverse plus B inverse times B times this whole thing on the right, B, A plus B inverse A. And so note that right now we have a right inverse to A inverse plus B inverse. To get the left inverse, we just multiply by the inverse of this whole thing on the right. Note that since this is a product of each of 3 different elements, each of which are units, the product is clearly a unit, so we have an inverse. So multiply on the right and left, on the right by the inverse, on the left by the same thing we have, and we get and so from this we have our left inverse, which is the same as our right inverse. And so this shows that A inverse plus B inverse, in fact, has a left and right inverse, and so it's a unit in our non-commutative ring. Thanks for watching. Please check out centerofmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.